Okay, we're going to do 6-8 today. 6-8, this is the last one that we're doing in chapter 6. After that, we'll have a little review study guide, and then just a little test, not a huge, big thing, but I'll give you all the details about that in a couple days. But notice in Google Classroom, it tells you a different way to sign up to get your assignments. For at least this lesson, we're not going to use our workbook because there weren't very many good graphing problems in there. And I wanted to try a different way just to see if y'all liked it. So you'll have to sign up on that website, use the code, and then I have to accept you into the class. So it might take a few minutes for me to get the notification that you've signed up. So if it's taking me a little bit longer to accept you, just send me an email and say, accept me into the class. And I will if you notice it's taking a little bit of time. But we are going to graph radical functions today. So we're graphing radical functions. Okay. And so that's just our square root and our cubed root that we're going to graph today. We're going to make some tables of values, do some transformations. I think you'll realize that most of the stuff we've done before, except we just haven't done it with the square root or the cubed root graphs. And make sure that you're taking your own notes for this, and that you're not just sending notes to other people, because they're missing out on things that I say that I might not necessarily write down. So if somebody asks you for your notes, say, I'm sorry, watch the video yourself. Maybe you'll learn something. Okay. All right. So the first thing we're going to do is make our table of values. If we have a square root graph, oh gosh, sorry, my voice is getting weird. If we have a square root graph, so we're just going to pick some x values that would make good things to plug into our square root before we plot our graph. Okay? So I'm going to pick some numbers for x that are perfect squares. So when I take the square root of it, it's going to be a whole number and I can plot it easier. So here's my x and my y. So I'm going to pick 0 because that's a perfect square. So what is the square root of 0? 0. Okay. Now I'm going to pick 1. What's the square root of 1? 1. And I'm not going to pick 2 because the square root of 2 isn't a whole number and I don't want to have to try to plot that. So the next perfect square that we have is 4. So what is the square root of 4? So I'm plugging 4 in for my square root. That's going to give me 2. And that will be enough points for us to plot our square root graphs. And I'll show you how to do that. And then we can figure out our pattern just like we had our pattern with our quadratics. Remember we went over 1, up 1, over 2, up 4. It's very similar to that. Okay. So now I just plot these 3 points. 0, 0, 1, 1, and 4, 2. And notice that I didn't pick any negative numbers because if you take the square root of a negative number, it does not give you a real answer. And we're not graphing this on the complex plane. This is the real plane. So we're not worried about any negatives. So this is where my graph starts, right here at 0, 0. And it comes up and it shoots across just like that. It looks kind of like half of a parabola turned on the side. Like if you finished it off right there, you could tilt your head to the side and see that that is just like a parabola. So we'll write down what our domain is and what our range is. We'll do that for all of these problems so that you'll get used to it. Our domain, that's where our x's start. So I'm going around the x-axis. My graph starts when x is 0 and then gets bigger. So x is greater than or equal to 0. And then my range, the y's start at 0 and keep going upwards even though it's slow growth. Y is greater than or equal to 0 for the range. Okay. Now let's notice what our pattern is so we can do our transformations because that's what we'll do next. So once I know where I start, I go over 1, up 1, right? And then go back and over 4, up 2. So we'll do that same pattern every single time as long as we don't have a number in the front of our square root. So that is over 1 and up 1 from the original point, and then over 4 and up 2 to get to our second point. So over 1, up 1, go back to the original starting point, and over 4, up 2. Okay. Now we'll do a transformation. We'll write down what all the transformations do, and you guys know this already, but we'll just I'll just remind you. And we're not going to do a stretch or compress. We'll just talk about flipping and shifting left to right and up and down. So if you have a negative in the very front of your function or in front of your square root, that negative is going to flip it over. Flips it over the x-axis. So instead of going over 1, up 1, you go over 1 and down 1. So if there's a negative in the front, your graph is upside down like that. Okay? If something is inside with the x, remember that's like inside the square root or inside the parentheses when we did our quadratics. That means it is going to the left or to the right. And if it's going to the left, it will have what kind of sign in there? You know this, but it's a positive sign. And to the right will be a negative sign. And then a number added at the end that's not inside of our operation, that's going to give us our shift up or down. Okay? And up would be the positive, down is going to be the negative. Sometimes you'll see this number in the front, but not touching the square root. And I'll show you one of those when we do our transformations. So we'll do 2 quick transformations, and then we'll do the cubed root graph, and that's all for today. So we'll try 2 examples. Let's say f of x equals the square root of x minus 2. Then we'll go f of x is, let's say negative, I'll put a 3 in the front, 3 minus the square root of x plus 4, just in case you see one right there, so that you'll know what to do. Alright, so we'll start with our first one. That is on the inside, so that means that we're going to the right 2. So we take our original graph that we had. Our starting point is no longer on the origin. Our starting point is now to the right 2. And from there we follow our pattern. So we went right 2. So our pattern was from that point, over 1, up 1, and go back, over 4, up 2. And connect. Okay, so we just shifted it right 2 units. And now we want to check back at our domain and our range, see if that's changed at all. Our x value now starts at 2, so x is greater than or equal to 2. And our y value didn't change at all because it didn't shift up or down, so y is going to be greater than or equal to 0. So it's all the y values above 0. Okay. Now for our next example. We see this 3 in the front, and we don't really like it there. I like to have those numbers at the end. This is a positive 3. Some people get confused because the minus is behind it, but it's what's in front of it. That's a positive 3. So I'm going to rewrite this. I don't like the way that it looks, so now I'm going to write it instead as negative x plus 4 and then plus 3. Now I'll write what all the transformations do. So this is a flip. And inside, that means we're going to the left 4. And we're also going up 3. Yikes. Okay, so before I get my starting point, let me see. I've got to go left 4, up 3. Good. So normally I go over 1, up 1, over 4, up 2, but I'm going down instead. So over 1, down 1, because it was a flip upside down. Then over 4, 1, 2, 3, 4, down 2. Okay. Check it. Did I get that right? Over 4, up 3. That's where I started. Down 1, over 1, down 2, over 4. And now I'll write my domain and my range. This one's a little bit trickier. Where's my x value start? Starts at negative 4, and it's everything bigger than that. So x is greater than or equal to negative 4. And then my range, oh, it's down instead of up this time. So where's the highest y value? The highest y value is 3. Okay, and our y values are everything under 3. So for our range, y is going to be less than or equal to 3. Less than because that one's going downward. So those are our square root graphs and the transformations that go along with it and finding the domain and the range. Forgot to put domain and range. Now we'll graph a cubed root graph, and I'll show you what that looks like and how you can sketch it and also do the transformations. That was square root, now we're going to do cubed root. So when we pick our x values, when we do our cubed root graph, we want to pick things that are perfect cubes. So if we're thinking about it, remember 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So we want to pick things that are perfect cubes. So I'll just start out, just because I know how this is going to look, I'm going to start out with -8 for my first x value. And we can do negative cubes. Cubes 3 is an odd number. Remember, we can do negative numbers underneath odd roots, just not negative numbers underneath even roots, like square roots and fourth roots. So the cubed root of 8 is -2. I'm going to do -1 next. And the cubed root of -1 is -1. I'll pick 0. The cubed root of 0 is 0. And then I'll go with 1, which is 1. And then 8. And the cubed root of 8 is 2. Okay, so if you notice, the numbers that are on the right-hand side are what I would normally pick if I were going to plot points. I'd normally do -2, -1, 0, 1, 2, but it's just reversed because it's the root instead of the actual cube. So now we'll plot these points and see what it looks like. See how awful I can draw this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 2 high and 2 low. And 2 slow. Alright, so I'm going to go -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. This one's fun to do. It's like a little snake curve, little S curve kind of. So here, and then whoo. So that is what your cubed root graph looks like. Cubed root transformations are exactly the same. We just move our center point. So that's what we would move, and then we would do our pattern for our cubed root graph, which our pattern is 1, 1, and then 8, 2. 1, 1, 8, 2. Okay? So if you want to write that down, we got 1, 1, and then we have 8, 2, and you also do it in the other direction. 1, 1, and then 8, 2 from the original point. 1, 1, 8, 2. 1, 1, 8, 2. Okay, because the cubed root of 8 is 2. The cubed root of 1 is 1. That looks like a crazy jumbled mess. Sorry about that. I don't think that we need to do an example on a transformation because you're just shifting it the same way. Numbers at the end, up and down, numbers on the inside, left and right, and I feel like y'all got that. So you should be good to go there. Remember, if you have any questions, you can send me an email, and if I need to talk to you, I can do it on Google Meets or whatever. And hopefully this makes some sense, you understand it, and you're good to go. Thank you very much. Good day.